Hello everyone, welcome to in 5 minutes. In this video we are going to see the problem on type 3 higher order differential equation. So this is our question. So if you can see in this part we have x cube x square and it can be represented as x raised to 0. So this is of the type 3 because here x is nothing but x raised to m. So as you can see, d cube y by dx cube and d square y by dx square and dy by dx can be replaced by, we are going to substitute d equal to d by x, then we will get d square equal to d square upon dx square and we get d cube equal to d cube upon dx cube. So now we are going to substitute this. We get d cube y minus 3d square y minus 3dy minus y equal to this term, which is 2x cube minus 3x square plus 1. Now from this equation, if I take y common, I will get d cube minus 3d square minus 3d minus 1 into y equal to 2x cube minus 3x square plus 1. So as you can see, this equation is now of the form f of d into y equal to x. So the solution for this equation is given by y equal to yc plus yp, where yc is the complementary function and yp is the particular integral. So we will find yc. So to find yc, we need an auxiliary equation, and auxiliary equation is given by f of d equal to 0. What is f of d? F of d is nothing but this term. Okay. So f of d is d cube minus 3d square plus 3d minus 1 equal to 0. If you observe this equation closely, this equation is nothing but d minus 1 the whole cube equal to 0. What is a minus b the whole cube? It is nothing but a cube minus 3a square b plus 3ab square minus b cube. If you expand this d minus 1 the whole cube using this formula, you will get this equation. So it is nothing but we have d equal to 1, d equal to 1, d equal to 1. That is, the roots are real and it is repeated thrice. So then yc is given by c1 plus c2 plus c3. Why I am writing 3 constant? Because the roots are repeated thrice. Then the second constant will be multiplied by x, the third constant will be multiplied by x square. Okay. Then we have e raised to mx. What is m? M in our case is nothing but root, which is 1. So m will be nothing but 1. So it is nothing but e raised to x. So this is our yc, complementary function. After this we need to find yp, and the yp is given by 1 upon fd into x. What is fd? Fd is nothing but d minus 1 the whole cube. Okay. And what is x? X is nothing but 2x square minus 3x square plus 1. Here is the hint. In type 3 problem, always represent f of d as 1 plus or minus some function of d the whole raised to n. So here if you see, it is d minus 1 and we have to represent this d minus 1 the whole raised to cube in terms of 1 plus. So in this we are going to write minus 1 plus d the whole cube. Okay. We need 1 plus, that is 1 should be positive. So I am going to take minus 1 common. So it will be minus 1 the whole cube into 1 minus d the whole cube. It's just I am taking minus 1 common. So what is minus 1 the whole cube? So it is minus into 1 minus d the whole cube. It's just that I am taking minus 1 common from this part. So it will be 1 minus d the whole cube. So if I substitute here, it will be 1 upon 1 minus d the whole cube and this negative sign here into 2x square minus 3x square plus 1. So as we know, in type 3 we take this part in the numerator, so it will become minus 1 minus d. Here it was plus 3, so it will become minus 3 2x square minus 3x square plus 1. After this we used to do a binomial expansion of this. Okay, so we are going to do the binomial expansion of 1 minus d the whole raised to minus 3. In general, binomial expansion is given by 1 minus x the whole raised to minus n is nothing but 1 plus nx plus n into n plus 1 upon 1 into 2 into x square plus it is 2x cube into n plus 1 into n plus 2 upon 1 into 2 into 3 into x cube. So in general, the binomial expansion is given by this. In our case, n is nothing but 3 and the highest power of x is cube, so we will expand till x cube. So minus sign will remain as it is, and here we are going to expand 1 minus d the whole cube. So first term is always 1. Then we have n into x. It is 1 minus x, it is 1 minus d. So in our case, x is nothing but d and n is 3. So second time is n into x, so it will be 3 into d plus n into n plus 1. N is 3, n plus 1 is 4 upon 1 into 2 into x square, so which will be d square. Then we have n into n plus 1 into n plus 2, so which will be 3 into 4 into 5 upon 1 into 2 into 3, so 1 into 2 into 3 into x cube. In this case it will be d cube. So this is the binomial expansion and so on. Why we are not writing more terms? Because the more terms will automatically become 0 if you see when we multiply this part, and this part will remain as it is.